Okay, today we are going to learn about factor by grouping. So factor by grouping is something that we've actually already learned. And let's look at this. We have to think about when we're provided a question and it says to factor the expression. So you can get an example that looks like this. You could get an example that looks like this. You could get an example that looks like this. Or you could get an example that looks like, let's go back here, that looks like this. Let's take that first one and add it to our list. Let me copy it. Or you can get a problem that looks like that. Let's put that in our order. And the thing that we should notice, that we should observe in each of these is the number of terms. Hey, this first one has 2 terms. So what typically has 2 terms? I would be asking myself, is this the difference of squares? This one has 3 terms. Well, clearly it's not going to be the difference of squares, but 3 terms typically remind us of binomial squares or A times C. So 3 terms, we would be looking at those techniques. 3 terms, we would look to see if it's a binomial square or A times C. 4 terms, well, we know it's not difference of squares because difference of squares always deals with 2 terms. We know it's not a binomial square because all binomial squares are 3 terms, and AC also deals with 3 terms. So what is this? This is FBG, factor by grouping. So when we start off a problem, we're going to notice that there are going to be techniques that lend itself depending on the number of terms that the expression has. So in these, you'll notice that all of them have 4 terms. So we are going to factor by grouping. They've saved us a step, and this is very similar to A times C. It's later on in the A times C process, we actually use factor by grouping. So we're going to look at the first 2 terms. What can we factor out? We can factor out a 2 as a coefficient and then n squared as a variable. If we factor out a 2n squared from 6n cubed, that leaves me with 3n. When we factor out a 2n squared from 2n squared, that leaves me with a 1. Something we should be aware of in this second group is my first term is negative. Since my first term is negative, I have to factor out a negative. So we have negative 15n and negative 5, which leaves me with, I can factor out a negative 5. If we divide that by negative 5, we get 3n plus 1. Did we do it correctly? We absolutely did because our parentheses are the same. So we're going to factor out that common factor, 3n plus 1, and that leaves us with 2n squared minus 5. Good. Let's look at this next problem. 2m cubed to 12m cubed plus 20m squared. Looking at the coefficient first, what's the largest number that is divisible into 12 and 20? That would be 4. And then we have m cubed and m squared. We can take out m squared. Both of them have an m squared. We're going to divide that. That gives me 3m plus 5. We're going to look at the next set of terms. 15m and 25. I can factor out a 5, and that leaves me with 3m plus 5. They both have a 3m plus 5 in common. We'll factor that out, and that leaves me with 4m squared plus 5. So that would be the answers for the first 2. And remember that when we look at these two terms. We look at them in pairs. So when we look at group 1, we're looking for the GCF. Remember how we find the greatest common factor of those two terms. We have 12n to the third, 12n to the third, and then we have plus 16n squared, plus 16n squared. So remember the technique. We're going to use prime factorization. We're looking for the GCF between those two terms. So we're going to do the prime factorization of both of those terms. 12n to the third, 16n squared. 12 gets broken into 2 times 2 times 3 times n times n times n. 16 is 2 times 2 times 2 times 2 times n times n. Let's circle what they have in common. They have a 2 in common. They have another 2 in common. They have an n in common, and they have a second n in common. So my GCF is going to be 2 times 2 times n, which equals 4n squared. So I'm going to factor out a 4n squared. Now, what's left? If we take a 4n squared, the yellows, if we take a 4n squared from 12n cubed, what are we left with? We're left with 3n. So that's what's left when we divide that or factor that from the 12n cubed. What's left when we take out a 4n squared from 16n squared is going to leave me with 2 times 2, or 4. So that's what we're doing. We're just factoring, is dividing or taking away those factors from those terms. So we would factor out a 4n squared, which gives us 3n plus 4. Let's look at the next term. Negative 3n minus 4. This is a tricky one. First of all, we know that we have to factor out a negative because my first term is negative. The other tricky part is if we look at the numeric, the coefficient, there's nothing they have in common. There's no factor that goes into 3 and 4 other than 1. And we can't take an n out because 4 doesn't have an n. So we're going to factor out a negative 1. And that leaves us with 3n plus 4. That is one of those tricky ones. So 3n plus 4, 4n squared minus 1. Oh, also tricky. Didn't mean to do that. We'll deal with it. This is going to come later after our assessment. We can still factor this. How do I know that? Something should have told you two terms, subtraction, and both are perfect squares. So technically, we can still factor that. That becomes 3n plus 4, and this becomes 2n minus 1, 2n plus 1, because this is the difference of squares. I wonder if that answer, let's look at number 3. Number 3, oh yeah, it did. All right. Hopefully there weren't other ones. Were there other ones with that? No, that was the only one, of course, Mr. Mac. Number 3 too. Sorry about that. That's pretty tricky. That's advanced, but it's all right. You guys can handle it. So let's take these groups. Let's factor out a 2b squared. That leaves me with 3b plus 4. Let's factor out a 1, and you get 3b plus 4 because nothing goes into 3b and 4 other than 1. So my answer is 3b plus 4, 2b squared plus 1. All right, well, you definitely got some challenging ones to begin with, and also on this one. We're going to keep on going with these toughies, but this will make you a better math student. We're going to factor out a 5m squared. We get 2m plus 1. We're going to factor out a negative 1. Gives us 2m plus 1. Remember, we can check by redistributing it out. Negative 1 times 2m gives me negative 2m. Negative 1 times positive 1 gives me negative 1. That has to hold true. Okay, so that's a nice way of checking also. Plus, we know we did it right because my parentheses are the same. 2m plus 1, 5m squared minus 1. Not the difference of squares. It is two terms, it is subtraction, but they're both not perfect squares. Okay, so that would be my answer. Let's look at these two. We're going to factor out a 2p squared. That gives me 2p plus 1. Let's factor out a negative 5. We get 2p plus 1. So my answer is 2p plus 1, 2p squared minus 5. Also not the difference of squares. So that would be my final answer. Group them. Group 1, Group 2. Where there is no coefficient that we can pull out, so we can only pull out variables. We'll pull out a 5r squared. You get 2r plus 5. We're going to factor out a 3, and we get 2r plus 5. My answer is 2r plus 5, r squared plus 3. Let's group. We're going to factor out a 5x squared. That gives me x minus 3. Let's factor out a 4, and we get x minus 3. The answer is x minus 3, 5x squared plus 4. Last two. Look at the first two. Look at the second two. First two, we're going to factor out a 3a squared. 3 goes into 9, 3 goes into 3. A squared goes into a squared goes into a cubed. That leaves me with 3a plus 1. We're going to factor out a negative 5 again, which gives me 3a plus 1. 3a plus 1 times the quantity 3a squared minus 5. And last but not least, let's look at these two. 9p cubed, 15p squared, so 3 goes into it. Yeah, I think 3 is our greatest common coefficient. P squared is easy, so we get 3p plus 5. 12p and 20, 4 goes into both of those. 4 goes in 3p plus 5. Yep, I did it right. Always a nice visual check if you did it correctly. And that's my answer. Come and see me if you got questions.